Hello everybody. So this is Mr. Hunter with a little podcast. It should take about 10 minutes on atoms and ions. And what I'm going to do is I'm just going to review these four basic areas. And so firstly, we're going to look at the basic atomic structure, then isotopes, electronic structure, and then probably most importantly, making or understanding ions from the atoms. Okay. So firstly, basic atomic structure. If you look at the periodic table, here's lithium and sodium, for example. You have two numbers which are really important. This one here is the mass number, and this one here is the atomic number. And the mass number is the number of things that have mass. And the things that have mass in the atom are the protons and the neutrons. And the atomic number is the number of protons. Now the atom is always equal. Protons are positive, so the number of protons is also the number of electrons. So for lithium, the atomic number is 3, so it has 3 protons. If it's got 3 protons and the mass number is 7, then the number of neutrons that lithium has is 4. For sodium, it's 23 and 11. We have a little diagram of sodium here. So you can see that because sodium is 23 and 11, it has 11 protons, 11 electrons, and 12 neutrons. We'll come to the electron configuration in a minute. Okay, so what I'd like you to do is just to test your understanding of this, just simply do these examples. So potassium is 39, 19, and let's see, phosphorus is 31, 15. Hey, I better check that. Let's just see. Yeah, cool. Okay, so pause the podcast and work that out yourself now. So I'm sure you did that. Now, potassium's mass number is 39, its atomic number is 19. So potassium has 19 protons. It has 19 electrons. And it has 20 neutrons, because you're subtracting the mass number here from the atomic number here. For phosphorus, mass number is 31, atomic number is 15. It has 15 protons. It has 15 electrons. The mass number is everything that has mass. It's the number of neutrons and protons. So it has 16 neutrons. I hope you got that right. If you did, here's a little smiley face for you. Okay, so that's basic atomic structure. What about isotopes? Well, let's find a new page for isotopes. Now, if you look at chlorine on your periodic table, you will see that it is unusual. It has a mass number of 35.5. Now, that's actually a little bit of a simplification. Almost all of the atoms in the periodic table will have an uneven number of relative atomic mass. So if I just find my periodic table, come on, hurry up. Here we go. So there's argon there, for example. Argon is 39.948. So all of them have unusual mass numbers, or non-integer masses. And this is because of isotopes. So let's explain isotopes. And we'll use the only example which is shown in the IGCSE or pre-IB, if you like, syllabuses, and that's chlorine, 35.5. So the reason why chlorine is 35.5 and that's a good example to use, is that there are two isotopes of chlorine. Isotopes are atoms of the same element with different numbers of neutrons. So this isotope of chlorine, number 35, has 17 protons, 17 electrons, and 18 neutrons. This guy here, however, has 17 protons, 17 electrons, and 20 neutrons. Aha! So they're different in mass. The electrons and the protons are exactly the same. Their chemistry is exactly the same. The chemistry is to do with the outer electrons and the attraction to the nucleus. So it's exactly the same. The only difference is the mass number. And therefore the mass is the only physical difference. So the relative atomic mass is the average ratio of the abundancy of these isotopes in the world, or in abundance, as it were. And you can do, using a nice funky machine called a mass spectrometer, you could actually find out the ratios of these. And the ratios of these are 75% 35 and 25% 37. So you could say if 75% of them are all 35 and 25% of them are 37, divide that by the whole, which would be 100, you get 35.5. Okay? And that's how you end up with a relative atomic mass of chlorine of 35.5. So a little problem for you. I won't get you to calculate stuff out, although you could. Oh yeah, hey, why don't I do that? I'll give you a little calculation problem. Bromine is a good one to do. Okay, bromine has two isotopes, 79 and bromine 81. But let's look at the periodic table. If we look at the periodic table, look at my accurate one. Here's bromine. It has a mass of 79.9, a relative atomic mass. I'm going to round that up to 80. That's probably what's in your the GCSE periodic table. Let's see, bromine. Yep, it's 80 right there. Okay, oops. So 80 is the number of bromine. So let's just go back to this here. Pause the podcast. See if you can work out, based on the relative atomic mass of bromine at 80, see if you can work out what the relative percentages of both of these would be. Well, I hope you were able to have a good think about that. You could either do it using, unknown x's and y's using mathematics, or you could just use common sense here. If this is 80, and one isotope is 81, and one isotope is 79, then 50% of all bromine is 79, and 50% is going to be 81. Okay? Right. So, that's isotopes. Remember the definition. Atoms of the same element with different numbers of neutrons. Now what I want to do is look at electronic structure. Electronic structure here. Okay? So atoms build up and in the periodic table, atoms build up. Ooh, not so good. Here we go, nice ruled line. So in the periodic table, atoms build up by increasing number of protons. Remember, that's the same number of neutrons because the atom is, the same number of electrons because the atom is equal. If you look at the way that the atoms fill in the periodic table, you've got one hydrogen here, two here. Now there's a new shell. So you see you've got 2 in the first shell, then 1, 2, 3, 4, 5, 6, 7, 8 in the second. Then 1, 2, 3, 4, 5, 6, 7, 8 in the third. So we can say that they fill up 2, 8, 8. So if something, for example sodium has 11 electrons because its proton number is 11, 2 will go into the first, then 8 in the second, then there'll be 1 left over. What about potassium? Potassium is number 19. Well, that means there'll be 2 in the first, 8 in the second, 8 in the third, and that leaves 10 plus 8, 1. So potassium is also like sodium in group 1. There you go. So, what that means is, if you're in group 1, you get 1 electron in your outer shell. Group 2, 2 electrons in your outer shell. Group 3, 3. Group 4, 4. Group 5, 5. Group 6, 6. Group 7, 7. And finally group 8, 8. And that's electronic structure. So given the atomic number, like carbon, you can work out the electronic structure. So carbon's in group 4. Alright? So why don't you do the electronic structures of magnesium and nitrogen? And from that work out what groups they're in. So magnesium, you do that now. Pause the podcast. So magnesium's in group, is atomic number 12, so it's got 12 electrons, 2 in the first, 8 in the second, 2 left over, it's in group 2. Nitrogen is atomic number 7, so 7 electrons, 2 in the first, 5, then 5 left over. Isn't that amazing? Okay, so that's electronic structure. Now, moving on from electronic structure to ions. Now, ions are charged particles which have lost or gained electrons. They've lost or gained electrons in order to be stable. Takes a while to write this out. Now they'll be stable when they have a filled outer shell of electrons. So, something in group 1 has a choice. Lose 1 or gain 7. It's easier to lose 1. So, substances in group 1, like lithium, electronic structure 2, 1, will lose that 1. If it loses that 1, well, it now has a positive charge. Now, why does it have a positive charge? Lithium, atomic number 3, had 3 protons. It also had 3 electrons. It had 4 neutrons. The charge on the neutral is 0. The charge on the proton is +1. The charge on the electron is -1. So the overall charge on the atom is 0. That's the atom. What does it look like for the ion? Well, for the ion, we said it was going to lose that outer electron. So if you like, its new configuration is 2-0 or just 2. It has 4 neutron, charge is 0. It has 3 protons. No protons have been lost. They're in the nucleus. Charge is +3. But it now has only 2 electrons, -2. Overall, that's a charge of +1. So lithium is plus. We say +1, but normally we just write the plus. Another way to consider that is if you say to yourself, right, well, the atom is neutral. In group 1, they're going to lose this outer electron. They're going to lose 1 electron, and that has a charge of -1. So 0 minus -1 is +1. What about chlorine or fluorine? We'll try fluorine. Well, fluorine is atomic number 9. Can't actually remember. Is it 19? Let's see. Yeah, so fluorine's number 19. Mass number 19, atomic number 9. So it's got 9 protons, 10 neutrons, and it's got 9 electrons. The electronic structure of fluorine is 2.7. It's in group 7. If it wants to become stable, it's going to gain 1 electron to become 2.8. So if that's the atom, which is a 0 charge, then the ion will have 10 neutrons, which is 0. You have 9 protons, which is +9. But it will have 10 electrons, which is -10. So the new charge is -1. And we would write fluorine as F minus or -1, but often it will just be minus. Okay. Again, another way to consider that is the atom was neutral. Because it was in group 7, it gained another electron. It gained 1 electron, and the charge on 1 electron is -1. So that equals -1, because 0 plus -1 is -1. Okay? So you try and work out now the charges on aluminium and the charge on oxygen. The ions, okay? You try that now. Okay, so hopefully you did that. I'll just go through them for you. Aluminium is number 13. It's got a mass number of 27. It's got 14 neutrons, which is 0. 13 protons, and 13 electrons. Aluminium's electronic configuration is 2, 8, 3. It's going to lose 3 or gain 5. It is, of course, going to lose 3. So the atom is 0, but the new one will be 0. It's lost 3 electrons. It's +3. Or you could write it has 14 neutrons, 13 protons, but now it only has 10 electrons. 10 electrons is -10, 13 protons is +13, 14 neutrons is 0. It's now +3. Aluminium +3. Okay. Now it's usually written as 3+, so you can write it like that. Although I can't see that it makes too much of a difference. Oxygen. Well, oxygen is number 8. It's got 8 protons. It's got 8 neutrons. It's got 8 electrons. 0 plus 8 minus 8. So the atom is neutral. Its electronic configuration is 2.6. To this 6, we are going to add 2 negative electrons. So 0 plus minus 2 is minus 2. So oxygen is 2 minus. Okay? So if you go back to your periodic table, you've probably seen by now that you can really make this quite easy here. I'm going to rub this stuff out just now. Get myself a new clean slate here. So what you can do now, if you're just looking at the ions, it should be clear to you now that if you're in group 1, it's plus 1. If you're in group 2, plus 2. Group 3, plus 3. Now group 4 could be plus 4 or minus 4. You're not really going to be tested on that too much, so just leave it at plus 4 just now. Group 5, minus 3. Group 6, minus 2. Group 7, minus 1. And group 8, 0. Now what about these guys in the middle? Well, because they're metals, they're going to be positive, obviously. Now they're between 2 and 3. The transition metals, as they are called, I want you to assume plus 2. Assume plus 2 unless told otherwise. Unless you're told, like for example, iron 3 oxide. Well, that tells you iron 3 oxide that it's 3 plus. There's other few exceptions. Silver is usually 1 plus. And chromium is usually 3 plus. But for now, if you just remember plus 2 and then watch for those Roman numerals, you should be okay. So those are the ions that the atoms of the periodic table form. It's all to do with their position in the periodic table and whether they gain or lose electrons. Now, there are a few polyatomic ions. Now these polyatomic ions, as the name suggests, poly, many, atom, many different types of atoms. Now these are formed when ions, whoops, don't want to do that. These are formed when atoms combine to form an ion which has got more than one atom in them. So carbonate here has got 1 carbon and 3 oxygens, all joined together by a process of bonding that you'll find out about later. And the 3 of them all together form this 2 minus charge. So the whole thing has a valency or charge of 2 minus or minus 2, not 3 or 6 or 8 minus or anything like that. You never ever interrupt these guys. They stay together always. So for sulfate, it's SO4. They stick together, but the overall charge is minus 2. For nitrate, it's NO3. The overall charge is minus 1. Hydroxide is OH. O and H together, minus 1. Phosphate is PO4, minus 3. Hydrogen carbonate, HCO3, minus 1. That means 1 hydrogen, 1 carbon, and 3 oxygens all stuck together, giving you a minus 1 charge. Finally, the only positive one that's in here, ammonium, not ammonia, ammonium. 4 hydrogens, 1 nitrogen, giving you a plus 1 charge. Now you need to learn these because they will come up in everything that you do here. So you need to learn these different names, carbonate, the symbols, and the charge. Okay? You can see I'm just having a little bit of fun with my new toys. So you've got to learn them so that you can do formula later. But for the moment, that's the end of this podcast, where we've talked about basic atomic structure, ions, isotopes, and electronic structure. And the next one that I'll do is on formula, where you will use these ions to show you how to make the formula of compounds. Okay? That's all from me. Cheerio. That's quite nice, isn't it? Bye.